Well, hello, good morning, and thank you for joining me here in my shop this morning. It's October 28th, almost the end of October here. So yesterday I assessed four similar radios to this one, two transoceanics and two worldwide, Hallicrafters worldwide radios. One of them works, that's the one that I own. The other three, not so much. I think I only tried actually powering up this one here, and nothing came out of it whatsoever. This is a nice radio when it's working. So, what to do next? So I've been studying the schematic a little bit. I'm determining kind of which model I want. There's not too many different models of this. There's an original tuner and an updated tuner. This is the updated tuner. I can tell from that number there, ID 2175. The update amounts to some minor changes and a couple minor components inside the tuner there. Another thing is the type of loop antenna or rod antenna that's in here. This is like again a later version of the radio. It has a place here to write the model number, but there's no model number appearing here. So, what is it exactly? Don't exactly know. I don't need to know at this point. I think, given the fact that hey, this looks like asbestos here. This box appears to have asbestos sticking out of the edges of it here. Wonder what's inside there. Probably because the radio's not working at all, no sound whatsoever came out of the speaker. Probably the right place to start is with tube testing in this radio. I often don't start with tube testing, I leave it for late in the game, but I think this one we gotta start right away with it. 1, 2, 3, 4, 5 tubes, and a couple of these are getting pretty rare. There's a 1L6 in here that is very rare. Now I see someone has written a note here. They've put 1US, or 1U5 rather, question mark. Wow, the question mark's good. What are they talking about here? Are they questioning whether a 1U5 goes there? Yes, a 1U5 goes there. Or are they questioning whether this is a 1U5? Why don't we start by looking at this guy right away. Well, it says 1U5 right on it. So, what's the deal there? I don't know. In terms of testing these guys, well, we might as well start on the left, and we'll just go across. So there's one back here. Before I put this in the tube tester, I'm going to show you the schematic. We're going to look at the wiring for these tubes. This is a 3V4, I believe this is the output tube. It's right next to the output transformer, which is sitting right here. That kind of makes sense. That's a good chance that's a dead tube. But let's take a look at the schematic here for a couple of minutes. Okay, fairly large schematic, so I don't have it all on the screen. There's a couple versions here, the Mark 3B, Mark 1B, TW2000, TW1000, and the TW1000A. This is the earlier version with a slightly different tuner here. I don't know if the rest of it's really any different. So I'm pretty sure this is the correct schematic, and what we want to take a look at is the plug coming in here, and how the tube heater string is handled. You're going to see that it's extremely complicated in this radio. Let's zoom in a little bit. Starting with the plug. So there's an unpolarized plug on the radio right now. It looks like a replacement plug, and the radio appears to have no transformer in it. It has no transformer in it. Which is a little bit surprising in a way, because normally you try to drop the entire line voltage across the tube heaters Well, these tube heaters are all 1.5 volt or something of that sort. I think the 3V4 is basically 2 filaments, so 3 volts across the whole thing. And also these are used as the cathodes. There are no cathodes in the tubes. How are they depicted up here? So they just show the heater and no cathode because there is no cathode. This means the heaters become really, really critical in the operation of the radio. And look at all the bits and pieces through here. Yikes! Look, there's a coil here. Let's see. Every heater's got a bypass resistor. Every one of them. 1, 2, 3, 4, 5 of them here. That's how many tubes are in here, right? 1, 2, 3. We have 5. So every tube has a bypass resistor. This is why if you pull one tube out, the other tubes, they continue to get supplied with power, only now it's more than what they bargained for. And there's strong warnings about this. Yeah, I think we could even find something right on the schematic here that says do not operate with the tubes pulled out. No, I'm daydreaming, I guess. Somewhere earlier in the service manual there was a big warning on a page. Do not operate it with any of the tubes out. So you gotta wonder what happens if one of the tubes fails. I mean, if the heater opens here, it's kind of the same as pulling the tube out. And I don't know what to say about that. Okay, so the bottom line of this is complicated and very critical, and you can't fool around in here. It's not like other radios. Very few radios have this kind of tube heater circuitry involvement. Look, there's a great big fat capacitor right in here. So the one I'm starting with is, I see 1U5, U4, U4, L6. This is a very rare tube, I believe. Somehow I thought this was an output tube. And 3V4. These are probably pretty rare too. Okay, let's just go through and do the tube testing. We'll see how that works out. Okay, let's start with the 3V4. So I'm going to dial up 3V4 here. Looking right over here. 3V4. Right there. So we set the filament voltage to 3. DX. DX was good last night on the shortwave radio, 6210. Zero. 31 and 68. 31. 68. So this control here I'm doing right now, it says English, is related to the words replacing good. So if you want to just use these words up here, flip this meter control to English and you get replacing good, as long as this is set properly. If you're on the actual scale, which I'm on here, actual scale reading, then this setting actually doesn't matter. Just so you know what's going on. Okay, so the tube should read between 820 and 1300. So 820 on the 3000 scale would be about here. So that would be at its worst case, and a good tube should be reading up around 13, up around here. So somewhere between here and here. Okay, we double check the voltage here because these tubes are intolerant. And maybe we'll even take a look at the line voltage adjustment here. It's right on. Okay, pop this guy in. Look for shorts internal to the tube. If there are some, this light will stay on here. Flashing is a good sign though. Flashing indicates there's charges building up, and that's a good thing. Test button is P4. And again, 820, 3000 scale, 820 is about here, P4. So this tube is very good. It's a winner. And that's the entire test right there. Yeah, that's it. Very good. Okay, so this tube is not the problem. And that's probably a good thing, because I'll bet you these are rare, although I hear the 1L6 is the rare one. There we go, that's back in. Just do this guy next. This is the 1U5. U5. Okay, we'll dial up 1U5 here. ST1U5 right there. 1.5 volts on the filament. DX 6210 with a 0. 6210 with a 0. 6210 with a 0. It's the very same as the last tube. Wait a minute, there's two 1U5s here. So this could be the detector tube. I'm not sure what it is. So see, 34 and 11. 34 and 11. We won't be using the English again. P4, this time it's between, yeah, it says here, pentode section. 330 and 525. So on the 3000 scale, oh, it's just barely coming up on the scale. I've never seen a tube who's, you'd think they'd, well, anyway. Here we go. Looking for shorts first. Watch for the light. Nothing happening. It's not good. Okay, P4, and again, it's just 300 just up here. I gotta plug the tube in for crying out loud. Okay. Okay. Just settle down now and make sure I haven't got any in a stupid position here. No. They want like, for instance, I don't have the tube plugged in. That would be a stupid position. There we go. Okay, these tubes heat up like that. Let's do the shorts test. There we are. Now we see some flashing. Okay. P4, just a little ways up. It was just a little ways up. So making an accurate measurement here, this would be about 300 on here. As accurate as this might be. And 1U5, 330. So it's low, but it's there. That's the thing. It's working. Let's go to the next setup. This particular tube tester, you can change these settings as long as none of these buttons are pushed. Other tube testers, you don't dare change the settings while the tube is in. That's what I meant, when the tube is in. So 6810, 6810, 1U5, 6810 with a 0, 34 and 0. 34, that's fine, and 0. Okay. Press P1. So this is, okay, so this is the detector tube. And incidentally, in a regular, more common radio with a regular 6-volt tubes, you'd find the detector tube has a triode in it. In this case, it's a pentode. It's a little bit different. But on the diode test, we push P1. Diode. The diode test, all it's got to do is get up past this mark up here on the meter. Okay. Did I already do that? I already did this, didn't I? Did I do it again? P1. Very low. Very, very, very low. So I get a low reading here. The first thing I think is, well, I didn't set the machine up right. So let's go through it again. So we're 1.5 DX 6810 6810 with a 0. 34. This is quite we'll do a sensitivity test with this in a moment. Nothing on the English. Diode. P1. Okay, so we're gonna look at. This shouldn't do anything in a bias. 34. You wouldn't think that the bias does anything on this setting, but let's fool with it. So I'm gonna move the bias a little bit and watch how much the meter moves. Yeah, it doesn't do anything. I don't know why they say bias 34. It's a diode. Okay, so the 1U5, very weak diode. We'd probably want to test this in another tester too. Okay, out you come. And the reason for that is you don't want to write tubes off quickly. Like I'm saying this to my wife all the time. If we go to the doctor, and this has not happened, but we go to the doctor and they take a test, they give us like a blood test, and then the doctor says, well, look at this result here. You know what, I'm going to put you on this medication and for the rest of your life. I'd say, no, you're not. You're going to take the test again. You're going to do the test again. You're not going to commit me to something for the rest of my life on one test, because who knows what might have gone wrong. And you know, every day's a little different for us physically. So same thing with scrapping a tube here. I would not commit myself to a lifelong medication without repeated testing, really, even if I had to pay for it myself. Same thing with scrapping a tube. It's a one-way trip when you scrap a tube. It goes in the garbage can, never comes out. You don't want to scrap tubes based on one tube test and one tube tester. Okay, so keep in mind, this guy, he just may not work. Would this be the reason why the radio is silent? No. The radio should have made a hiss, a click, a pop, anything. It didn't do a thing. And that's really odd, because the output tube is working. Okay, let's keep going. We'll do the next one here. Wow, really in there. This is a 1U4, and it might be wise for me to just take a peek at the diagram that shows. Do I have a quick one here? Shows where the tubes are, just to be absolutely sure. This should be V1. Okay, now I know it's V1, but what is V1? Just bear with me a second here. Somebody tell me. Here we are. 1U4. This should be a 1U4, and it's a 1U4. Good. Chances of it being the wrong tube, better than you might think. 1U4. Okay. I'm just leaving the video running today. I'm not editing it down. 1.5 volts. DX 6210. 6210. 6210. With a 0, 14 and 43. 14 and 43 if we care. B4 570 is the reject point. Okay, this time I'll remember to put the tube in. All tubes test the same when they're not plugged into the tube tester. Okay, looking for shorts. Seeing a flash on the short light. Looking good. 4, 570. So 570 is about here. She's a good one. Bit of heat there. There's a tube. There's one tube inside this tube tester. Is there one tube inside that tube? I've got too many tube testers. There. Okay, I'm gonna get out the next tube. Here. Excitement's over here now. So we've done the 3/8 down here. Now we're going to do the 2 up on top here. Pretty good tube sockets. Another 1U4. That's good. That's efficient tube testing. Okay, 1U4, and we are still set on the 1U4. Just because I don't trust myself at all. 6210, 6210, yeah. 1.5, in you go. Wow, this is a tough tube socket here. Wow. Holy smokes. I replaced the tube socket here a couple of weeks ago, and I put one in that's pretty grabby. Okay, any shorts in this tube? I would guess certain shorts in these tubes in that kind of radio would cause havoc. And the same thing again, just up above 5. Great. Excellent. So far so good. Now, people tend to think that the tubes in old radios are all shot. And so I've had people tell me they've bought an old radio and immediately ordered a set of new tubes for it. And of course, they're not necessarily brand new tubes either. And I always tell them, no. Don't do that. Here it is, the 1L6. This is the rare one. This is the one that's hard to get now. And why exactly? I don't know. I thought it was an I just assumed it was the output tube because those have become rare. Let's not blow this tube now. 1L6. So we'll look for 1L6. There's two tests in a 1L6. So 1.5 volts. DX 6251 with an 8. 6251 with an 8. 1L6 6251 8. 6251 8. I'm not making any mistakes here. I'm making absolutely sure I don't get this wrong. 1839. Pentode section. The expected reading is 500. 1.5. Now, do I have any of these tubes? I don't know offhand. I have a special container of them just over yonder here. I can just take a quick look and see if there's 1L. Uh-oh. I don't see a tray with 1L6 on it. Okay, looking for shorts. Okay, flashing. We can be hopeful now. It does flash. Again, 1L6 on this test, 825. So up about here. Here we go. Ooh! Bam! That's not good. It's just barely moving. You can barely see it move. Oh boy, oh boy, oh boy, oh boy. Okay, settings wrong. Settings wrong. 1L6. DX 6251. 6251 with an 8. That's an 8. 18 on the bias. 18 is on the bias. 39 English doesn't matter. Well, there's no denying it. This tube is a sick puppy. Could this be responsible for the radio being so quiet? I don't know. There's another section here to test. 8152. So DX 8152 with a 6. 40 and 73. 40 and 73. This is a real pleasure to use. This particular tube tester is very popular and it's very nice to use. P4 Okay, so it says, oh, there's a note here. Micro modes only, okay, over 7, I can't read the number there, 700. I think it says 700? 200. Then it says oscillator section. So what it's warning you is that if this, like a lot of tubes, if they're weak, the volume is lower on the radio. And you can turn the volume up, get a little extra noise, a little extra hiss, but you still get it. With an oscillator, when they get weak enough, they can't trigger the oscillation anymore, and the oscillation just quits. And I think that's what they're trying to warn here, that you know, it's supposed to be 300. Oh, there is no reject number written here. Micromodes okay, only okay over 200. Why didn't they just put 200 here? Only, it's a weird way of putting it, isn't it? Micromodes, that's the measurement. Only okay over 200. Okay, never seen that note before. Let's give it a go. 81526, 81526, because I just have so much doubt in myself. Okay, what about a short? A little slower there. No shorts. We're pressing P4. Got to get over 200. Well, 200 is just here. I mean, it's hardly going to move it. No, it doesn't do it. So I'm going to guess what has happened to this tube is the cathode, I was going to say the cathode's worn out. There's no cathode. Is it a coated heater in these tubes? I don't know. The heater's still operating on it. Well, okay, so 1L6, just kind of what you don't want to hear. Put it back in the radio for now. That was the last one, wasn't it? So let's look at the schematic in a 1L6 and what's it doing? What's it doing in this radio? Okay, so this dotted line is the metal outside of the box of the tuner. And sitting on top of the tuner box are these two tubes. And one of them is the 1L6. It's the mixer oscillator. Yeah, I thought this was an output tube, only because I hear that they're very, very scarce. But why would this tube be so beat up in this radio? The other tubes seem fine. Why this guy? So I'm going to take a guess. It's not that all the other tubes have been replaced, and this guy never got replaced. That's not what we're looking at. I think they're good chance they're all original. This guy may have taken a beating because it's an oscillator tube. And oscillators work hard, can work very hard, and that could literally, I guess there's a coating on the filament. I'm not sure whether it needs a coating or not. But there's other factors too that could cause it to lose its power. What to do about it? The only thing we can do about it is replace it. I have to find a 1L6. Is it possible something else is something has caused this tube to be ruined, and I put another L6 in there and it's out the window within 5 minutes? Possible. I don't think it's very likely though. Is there something I could check on this? I could check these voltages, but you know, 91 is probably the highest voltage in the radio. There's 95 there. So I mean, it can't go high. 92 on the output tube. So you know, 100 volts is the limit. It's there already. I'll have to look for another tube. That's the only hope here. Actually, I have a separate tray for these tubes. And does anybody see 1L6? Oh, 1L6. There's one in there. There's one. Let's check it out. I don't know what these are worth. These are worth a lot of money. It's a funny thing about, put this tube in the radio, and the radio is only worth so much. Take the tube out and hold it in your hand. The tube might be worth more. than the radio. Figure that out. Okay, we're going to do the 1L6 again, and this guy is still set for a 1L6. 8152. 8152. Okay, is this going to work? If I've retained it, it's probably because I've tested it, but I'm not exactly sure of these. The only tubes I retain are ones that have, you know, conducting heaters and show some life in them. Like that one L6 we tested with this, that's not showing any life. That tube would go in the garbage. Actually, it goes in a box of dead tubes. You know, I can't even throw them out. I have a gigantic box with 150, 200 dead tubes in it, maybe more. Okay, looking for shorts. You're seeing the flashes? Makes me feel good. We're pushing P4, and in this, yeah, P4, and this is the got to be over 200. It's over. It's kind of just at 200, but it's there. Okay, we do the other test on it. This guy's going to go on the radio. We're going to give him a test. 6251. 6251. I got this right. 1L6. 6251 with an 8. Remember so many changes. 6251. 18 and 39. 18. 39. Oh, scared me there. 39. Press P4, 520. So P4 up here. Let's do the shorts just in case. This is a really crappy switch here. And P4. Oh, way over. She's a beauty. Do I risk this now? I got a 1L6. Am I just gonna risk it in this radio? How much of a risk is it? I don't think it's much. So we're gonna take out the 1L6 that's in here. 1L6. We're gonna put it over here. I'm gonna take the good one. We're gonna stick it in. Hope we don't blow it up. What I do with tubes that are bad is I bend one pin inwards like that. That's all it takes for me to mark that this is a bad tube. So if it rolls around my bench here for a couple of days, it won't matter. I will realize it's a bad one. And while we're talking about bad tubes, can you see the black material inside? You can't obviously see the black material building up on the inside of the glass on this tube. Was that the letter S in there? I think it's just because of the shape of the opening just in behind there. See, there's an opening in the plate just behind it. And this stuff must be shooting out and striking the glass and adhering to the glass. There's an opening in the plate in there. Can you kind of see it? Hard to see, but just where my finger is, there's actually a little window. It's as if they cut. You can see it there. Yeah. Like they cut three sides of a square and then folded it open a little bit. For some reason, who knows why? To let this black stuff out. Let it out. Well, the reason I'm showing you this is a tube that's worked hard. I think that's what this means. This tube was likely to be worn out or worn down to some degree. Tubes actually do wear out. Okay. I think we're ready to try this radio again. So I'm going to stop and go drink some coffee. Okay, let's see if this one tube made a difference. Could that tube have made the radio completely silent? It's possible that because of other factors, the radio was completely silent. Like, for instance, I may have had the volume turned down. I don't know. It sounds kind of stupid, doesn't it? Yeah, definitely sounds stupid. Okay, switch is off. Plug is going in. is on. Switch is off here. 118 volts coming. And we're on the broadcast band here. One of the things I learned about this radio by looking in the manual is none of these are lit. I'm not sure what that means. They're all lit with white. Why did they do this? When it's all white, that means this band you can hardly see on the camera is the one that's operating, and this, I believe, what is going on here? It says long wave. Well, you got me. I don't know what to say. Okay, we'll have to look at that later. Something. And plus, the color thing it drags, so we got to help it out a little bit. Make sure it's showing the right thing. So we're back on broadcast band. Okay, here we go. Just for a minute, I thought, wait, there's no speaker. Yeah, the speaker's right behind here. Okay, here we go. Dim bulb came on.
A new home. Really good.
What happened there?
Affordability is the issue.
What happened?
Those are the two markets, and unfortunately, Doctor, this won't help on new homes because it's pretty tough to find a new.
Well, I don't know why it popped on suddenly. Okay, we're running it with 100 volts, which is enough. I still have the dim bulb in.
Benefit in the smaller communities where prices are not as. Said it was $1 billion, first of all. With the Cardinals number of $347 million in savings, I've said before, even if it's half of that, I'd take it. How gobsmacking is it to have her say that $200 million is just not worth the effort?
Huh? What's he talking about? 200 million, not worth the effort.
I thought, guys, when they played it last tonight.
Is that where the pop came from? Dirt in the capacitor. You know, is it dirt in the capacitor that's made it go quiet? How come it's stopping here? It's stopping here. How come it's stopping? The capacitor is closed. The pointer is 18 miles out. It should be over here on this row of dots.
Way.
No, it's just very
out of the market, not just
very, very quiet between stations. Loud enough. I think what we're seeing are alignment issues here. Goodness knows if this radio was aligned with the pointer where it is now. Goodness knows. So this is 820. It should be way down here. 860, right? Way off. Way off. Is that about the same? Yeah, it's about the same. So pointer on the string. And then we'll be able to go way off on this side. Oh, we're stopped. We're stopped. How come we're stopped? So let's see, the capacitor is only 2/3 of the way. The pointer doesn't want to go any further. What is stopping it? Let me turn this a little bit. Oh, nothing's stopping it. What happened there? Could be a string overlapping. Could be happening down here. Could be having a string overlap taking place down in here. This has got the scooped bobbin shape here. There's a lot of dirt in here too. So that's probably what I was experiencing. The string was probably going over top of itself there. Yeah, maybe right there. Okay, so we can go way off though. We can go all the way to there. So somebody's met his end, but not the capacitor. That pointer, I guess the pointer is, no, the pointer still got room. I don't know, let's not force it anyway. So we got to move the pointer on the string.
ladder, pointer
I forgot the radio was on. It's so quiet. Okay, let's listen to the quality of the sound here.
It's so casually blown off by the budget chief. Matt, you don't matter to Shelley Carroll. That's how that looks to me. 416-872-1010. 416-872-1010. Toll free 877-518-5151. I only have a couple of minutes left here, but it's just stunning, astounding to me that the thing come on the air and just so casually blow off something that was demonstrated not just by research from Cardis, but research from Cardis involving other communities.
Fading out.
That could save
Is it
hundreds of
fading?
millions of dollars. Why don't those things that could be
It's fading away right now. Well, that's not good. It just faded away. Old radio. Oh, what? I bumped the volume control. Oh, is that why it was fading? It's fading away because I'm turning down the volume. Was it? Did it? Is that what it was? I'm not sure about that now. Sometimes if the radio is fading and you turn it off and on, sometimes the fade will start over, you know.
En fait, on a travaillé avec un professeur sur la communauté libanaise ici à Ottawa, et il nous expliquait qu'à l'époque, à la douane,
It doesn't sound distorted now.
De laisser passer plus facilement les personnes qui venaient de cette zone-là en guerre. Donc,
What happened there?
les douaniers n'étaient pas stupides, ils voient bien que tous les papiers sont pas en règle, mais ils les laissent quand même rentrer, ils comprennent qu'ils viennent pas en vacances comme ils prétendent. Et...
Weak station sounds distorted.
Tiré de votre vie.
Oui, mais j'ai demandé à mes parents, est-ce que vous avez encore les passeports?
Did I knock the volume down again? Yeah, I can see how the volume gets caught in this control. Come on, radio. I thought there were stations down here, weren't there? What happened? What happened? It fade out again, and I didn't have sound on to hear the fade out. Off. Okay, back on. Oh, did I get it off? I did not get it right off. Okay, it's off. And back on.
Et ça bon, plusieurs réflexions. On écoute l'extrait puis on en discute. Mais bon,
Okay, I'm going to leave this running, not touch it, and we'll see what it does. I go drink some coffee. Okay, so I was just in here, I was going to look up the price of a 1L6, and while I was doing that, the radio was working fine, and then it very quickly faded out. It went out in a matter of about 10 seconds. It just went gone. That sounds like a tube losing its heat. Could be a tube loose in the socket. I don't like any of this. Could be lots of things. So first thing to do is shut the set off and see if it'll come back afterwards. So shut it off. Usually if it's a heating thing, the tube heats up and cuts out. And when it cools down, it comes back. I usually get a. This just went out. So the going out thing could be charge leaking through a capacitor, pushing a grid bias off slowly and getting it to the point where it chokes out the tube in the end. When we turn the set off, the voltage dissipates, and then we start up again, the voltage begins to leak through, or the voltage doesn't leak, but okay, let's try it.
Dans cette série, c'est que on s'identifie à tout, peu importe, pure laine, immigrant. D'ailleurs, c'est un immigrant qui est
Going down and out. That was pretty quick that time. Still hear the hum. I can hear the hum in here. Turn it way up, you can hear something. So circuits beyond the volume control appear to be working normally just from that. Oh, I just heard a little pop in here. Didn't come back though. That could have been anything. Could have been a light being turned on in my house somewhere. Could have been anything. Okay, let's shut it off because you know, if my theory of the leaky capacitor is true, then we've pushing a grid bias where we don't want it to be. Could be cooking a tube, possibly. The other thing about it is it did not go through terrible distortion on the way out. It just got quiet. That usually suggests a heater. But we can't know. We can't know right now. How can we know? How can we figure out who's doing this? What is doing this? That's a tough one. That's tough. If I put the tube in the tube tester and leave it running for a period of time, perhaps the same thing will happen in the tube tester. Maybe. I don't know. I gotta think about this a little bit. Intermittent problems are always difficult to track down. This isn't exactly intermittent though, is it? Well, after giving this some thought and looking at the schematic, yikes, there are so many possible things. The first thing I would have thought of as a shot in the dark would be the grid blocking capacitor on the output tube. But, you know, so as that capacitor leaks charge onto the grid of the output tube's performance goes down, down, down. That usually comes with a lot of distortion, and I don't think it silences that tube. Besides, the volume control seemed to still be affecting something coming out of the speaker, so I think the whole audio circuit is fine. The problem is earlier in the radio. Wow. Could be a tube. I'm not sure of that. I would guess if a tube heater is opening and closing, each time it does that, there'd be a pop in the radio. But there was no sound whatsoever. So, and it never came back. The open heater thing usually opens and closes, this thing just went one way. So one possibility is just to get in there and get rid of some of the bad capacitors. And let me remind myself, how many bad capacitors? Is this thing full of bad capacitors? I can't remember. I think we laid it right on its face, didn't I? Do that. Yeah, it's not a lot in here, really. The other thing that's got me a little bit wondering is what's going on with this guy. So it's got this diode, like a silicon diode, soldered in, but this is still connected in the circuit. So I'm not sure about the wisdom of that. I thought you would want to remove this entirely by, you know, clipping the. I don't know what that means. This is an open circuit, and so they just put another diode in. Or is that supposed to be there too? I don't think so. So I'm going to call it quits here for today. Just notice this capacitor and this resistor are soldered to the chassis here. So this is an important capacitor to be aware of. yeah, many things to be aware of. Why the asbestos? What did they think was going to happen, or what happened in earlier versions of this radio that they think they had to put a little sheet of asbestos right in here? Very mysterious to me. I mean, it would have to be, I don't know. Maybe there's a big hole and they're covering the hole. I don't know. Lots of mysteries. Well, we're going to leave the mysteries till tomorrow, and I will pursue this another step of the way and see if we can get it back, see if we can get this thing working again. Yeah. Thanks a lot for watching. Have a great day.